Good morning, good evening, good afternoon, wherever you're hailing from. Welcome to another episode of OpenShift.tv. I am Chris Short, Principal Technical Marketing Manager on the OpenShift team. I am joined today by my fellow teammate, the one and only Andrew Sullivan, Mr. Virtualization himself. Andrew,
Well,
please introduce yourself.
hello, Mr. Chris Short.
Hello, sir.
So, yes, good to be here again. I think this is my third or fourth one of these now, something
Yeah,
like
something
that.
like that. Yeah.
I'm not internet famous like you, but maybe in a few years.
We'll get there.
Um,
We'll get you there.
yeah. So, as you said, we are teammates. I tend to focus on anything virtualization related that isn't also OpenStack.
Mhm.
I'm not an OpenStack person. I freely and openly admit this and make no claims otherwise.
As do
Uh,
I. This is
Yeah.
good.
Yeah. So, funny enough, we should be joined by Rhys here in a few moments, who is an
Mhm.
OpenStack expert on the other hand.
Interestingly enough,
Uh,
yes.
so, yeah, between the two of us, we've kind of got all of the aspects covered. But that's not why we're here today, right? That's only part of why we're here today, right?
Small part.
So, really, and I think I put in the request for this one. I filled out the form, which, by the way, that process works phenomenally. So, thank you for setting all of that stuff up.
You're quite
Um,
welcome.
Yeah, so the impetus for this particular session was a conversation that I had with, among others, Burr. So Burr and a handful of other people all reached out to me within the span of like 2 days, and were asking basically the same questions, which is, how do I actually create VMs? Right, when you look at the demos and all the other stuff, even the last time that we did an OpenShift virtualization live stream, both Rhys and I kind of, hey, we have this image and it's on a web server, and kind of skip over that whole part. So my goal today is to dig down into those virtual machine disks and data volumes, and how do we install an operating system on a virtual machine? So and the second part of that is, how do we then expose those virtual machines? So in a perfect world, fingers crossed, what I'd like to do is be able to one, install a virtual machine, and then install something like stand up a web server or something with Podman, and then expose that out to the outside world. And maybe we can play around with SSH or something like that, see how we can get access via SSH.
Okay. And just
Oh,
like that, here comes Rhys.
all right. Well, now that the man of the hour is here, I'm going to go ahead and hand it off to him for the next 3 hours of streaming.
This is amazing. Let's go, Rhys. Hit it.
Oh boy, what did I stumble into?
Hey, Rhys, welcome. Please introduce yourself to the audience. Andrew pretty much just got done introducing himself and telling everybody what we were going to cover today.
Fantastic. Yeah, thanks, Chris. Thanks, Andrew. So my name's Rhys Oxenham. I manage what we call the field product management team. So we spend a lot of our time working very closely with customers all over the world with their OpenShift and virtualization projects. And this is not my first time on the stream. We did a similar one. God, when was it? Back in May, maybe?
Yeah, it was
It was a
like
while
in
back.
the beginning of the OpenShift TV days. Yes.
That's
Yeah,
it. So it's
yeah.
good to be back. I'm
You did
surprised you have me back.
You did such a phenomenal job. How could we say no?
Yeah, I mean, what's the complaint here?
No complaint.
Got it.
More surprise.
All right. So now that you're here, Rhys, I won't delay anymore. I won't do any more tap dancing, and just kind of move ahead. And yeah. So what you're looking at here is an OpenShift virtualization, or an OpenShift cluster that's deployed inside of my home lab. So the last time that Rhys was on, Rhys was leading the OpenShift virtualization session, and he walked through kind of setting up exactly what I've got inside of here. So if you go to demo.openshift.com, look for the OpenShift virtualization category, and then down towards the bottom is a link to the GitHub repo that has how to deploy all of this infrastructure, everything that I'm going to be using inside of here.
Oh my goodness.
I did make some changes.
Which the bottom one. Got it.
Yeah.
Thank you. Sorry. Go ahead.
Here, I'll bring it up. I'll bring it up because
I'm going to drop it in chat real quick.
Yeah, so if we come all the way to the bottom, because they're alphabetized now. Thank you, Eric.
Thank you.
And then if we come towards the bottom here, we have this self-paced learning and demo environment. And right here in this repository is a link to all of the good work that Rhys and August, and I think a couple of others have done in order to make this stuff easy to deploy and consume in your local environment.
Mm-hmm.
So one thing to note, and I know Rhys and I talked about this the last time. Yeah, in our lab, we are using nested virtualization. Just remember that that's not supported by Red Hat. So if you go to deploy in your environment, you want to use a production environment. Just make sure it's running on bare metal, not in a nested setup. All right, so with that out of the way, I'll quickly review my cluster here. So super simple. This is 5 nodes. You see I have 3 control plane nodes, 2 worker nodes. In my instance, these all happen to be running on a Red Hat virtualization instance as opposed to a local libvirt instance. But otherwise, they're exactly the same. If you were quick, and I didn't highlight this before, I am running the most recent stable version of OpenShift, so 4.5.4.
Nice.
And if we look at our installed operators, you can see that I've only installed the OpenShift virtualization operator. So if you remember the previous stream, the last time that we did this, I think we did 2.3, I think was the version we were doing.
2.3.
Yeah. So 2.4 is now generally available. You can see we've got a fancy new icon and all of this other stuff. If we come inside of here, some things have been renamed. If you've seen the demo video that I did, I spent Aubrey, our PMM, called me out. She was like, you spent like a minute and a half just talking about naming and how things have all these different names. And that's because as marketing does, the name of things changes. So what started out as, what was it? Container native virtualization turned into OpenShift virtualization. And as a result, we have a couple of different names. So you'll see CNV, container native virtualization. So just don't be alarmed by that if you go to deploy. So the other thing that we can do here is if we look at our workloads, and I'm not going to rehash all of this stuff because it's covered in the other live stream as well as a bunch of other material that we have. Basically, all the services inside of here are deployed. And the one that we can really care about today is going to be the CDI services, the containerized data importer. And we can also come over here to our command line, and I will reiterate and refresh that I cannot talk and type at the same time. So my apologies if anybody is expecting that.
Is this about KubeVirt? There's a question in chat. Yes, Oleg, this is about KubeVirt, basically.
So KubeVirt is the upstream project for OpenShift virtualization. So like everything Red Hat, we do everything upstream open source and then bring it downstream as a productized version to provide support, et cetera. Inside of there. So what you'll see is much like, I just did a OC-get CRD, the custom resource definitions, and grep for KubeVirt. That's because everything is defined in the KubeVirt API namespace inside of here.
Nice.
So conveniently, it's all highlighted in red, so you can see that. So again, the ones that we're going to care about here are really these ones up at the top, the CDIs, and in particular, data volumes is what we'll be looking at today. All right.
Sweet. So Eric and I were having a discussion earlier about music for the channel, and you're one of those people that can't talk and type. Are you one of those people that can type and listen to music? That's the question. Okay.
Yeah. So generally, I always have some kind of background noise.
Right. And that's what I was thinking. And I was like, yeah, let's have like some, nice mellow or, interesting background music. And this
elevator
would be the time
jazz.
for that. Yeah, not like elevator jazz, something a little more modern.
A little smooth jazz going on.
A little Yaz flute, maybe. I mean,
that might actually be distracting.
Yes.
Okay. So I have OpenShift virtualization deployed. You see when you deploy it, we add this convenience GUI integration to the virtualization menu item. And normally when you go to create a virtual machine, you would either do it through CLI, right, create a YAML object, or in particular, when we're wanting to illustrate something, we use the GUI because it's just easier to show all the different options. So the last time I talked about all the different sources that are available here: Pixie, URL, container, and disk. And these are the things that we want to talk about today, which is how do I populate these? How do I get a URL, or how do I create a container image that I can then attach to my virtual machine?
I have a personal question to ask.
Sure.
Do we know, and this might be for you, Rhys, what function actually, if you go by URL, what downloads the image itself? What piece of code? Do we know?
Yeah, well, we start a pod called the importer pod, and that's just simply going to pull the the QCOW2 or the raw disk image directly from the URL source that you provide. And it's essentially going to write it out to wherever it needs to go. If that's just onto the local file system and a host path, or if that's on NFS share, or onto something like Ceph, if you're using OpenShift Container Storage, it's going to write it out directly there. So nice. It's code that lives essentially within the CDI space.
Cool.
Yeah. So all I did while you were chatting there, Rhys, was browse to the RHEL download page, right? So I'm just looking at RHEL 8.2, which is the latest non-beta version available. And if we look in the downloads here, there's a couple of things that we want. So the first is this KVM guest image. So this is going to be a QCOW file, and it contains that base OS disk. So I'll go ahead and kick off that download.
Does it also support however you say that, QEMU files? QEMU, yeah.
Yeah, so the disks will end up being either QEMU2 or QCOW2 or raw disk images.
Okay.
Either one of those will work.
Cool. Thank you.
So the other thing that I'm going to download here, so I downloaded the KVM guest image. I'm going to download the RHEL binary DVD. And hopefully this doesn't absolutely kill my internet connection. It should be fine.
Oh my gosh, I thought you had like super high-speed internet or something.
Yeah, it's gigabit, but with the streaming up and down and everything else, we'll see.
Oh.
Here, it's not bad. It's going
I was
at
about to say.
merely like 250 megabits between the two.
Oh, that's all? You poor baby. Me here with my 120 up and 20 down, or whatever it is. Vice versa. Yeah, I said that wrong.
The research triangle has its advantages.
I know. Yes, being out in Detroit is interesting.
So the other thing that I'm going to download is the Fedora Cloud image, just to use as a second example here.
Oh, cool. Okay.
And you can see all we're doing here is Fedora Cloud. Let's see, now it's starting to slow down. Come on.
Oh.
Yeah, that's because the page jumped on me, so it didn't see.
Oh, the page did jump on you with your fancy clicking.
I know. I was moving too quickly for it.
I do appreciate the ads that you have, though. I'm trying to sell you hats.
Yeah. So
thank you, Google.
So all I did, you saw, I did a quick search for Fedora Cloud image. It's going to take me to cloud.fedoraproject.org, which will then redirect to alts.fedoraproject.org. And I'm just going to download this cloud-based image for OpenStack. And yes, I do want to save that. So last but not least, so remember OpenShift Virtualization has the same guest OS support that Red Hat Virtualization has. So officially, we only support the various Windows, so server and desktop from, I think, Server 2008 R2 on and Windows 8 on or something like that, and the RHEL variants. Other operating systems like Fedora will work, CentOS will work, just remember we don't officially support them. So I say that because you can also search for OpenStack cloud images, and the OpenStack team very helpfully has this page that lists a whole bunch of other distros that you can get with cloud images. So here's CentOS, here's Ceros, Debian, Windows. It even tells you how to create the Windows images, et cetera, et cetera. So these aren't the only options. These are just the ones that I'm going to use today.
And this actually highlights a really important point. With OpenShift Virtualization, we are building on top of many years worth of experience, expertise, but also technical capabilities. OpenShift Virtualization is using the same underlying stack. It's the same Red Hat Enterprise Linux. It's the same KVM, same libvirt. It's just being orchestrated in a slightly different way. And so, yes, we're looking at OpenStack images here, and you can use OpenStack images on top because they're all utilizing very similar underlying components to instantiate them. So OpenStack images will work just fine on top of the platform. In fact, OpenStack images typically rely, especially if they're a Linux based, on Cloud Init. And that's exactly what we heavily utilize inside of OpenShift Virtualization as well, to get customization and automation into them.
Nice.
Yeah, exactly. And you can build images other ways as well. If you already have, for example, Packer as a part of your process, you can use Packer to output a KVM image and import that and use that.
Mhm.
If you have a base image for RHEL or Fedora, whatever it happens to be, you can use Vert Customize and customize it that way, and then import it in just like you would with any traditional KVM based image.
So a few questions here, if you got it. Second form, does it support GPU assignments?
Off the top of my head, I don't know the answer to that.
So you can do some PCI assignment.
Okay.
So there's a big difference between GPU and vGPU. So GPU would typically be where you're passing the entire card. So it wouldn't really matter whether it's a GPU or some other PCI device. That's kind of irrelevant. There's the ability to do that. But vGPU is slightly different because the orchestration platform, in this case, OpenShift Virtualization, essentially has to instruct the underlying card to carve itself up into vGPUs. And we typically do that with NVIDIA and the grid driver and things like that. Now, we've had the capability to do that with Rev and OpenStack for a very long time. Some of the capabilities on top with OpenShift, I believe you can do, but OpenShift Virtualization requires some additional configuration because we're, of course, defining a virtual machine through an OpenShift API. So I think we're still working on the vGPU capabilities.
Okay. Good answer. Good answer.
Yeah,
thank you for that.
I'll look it up.
Appreciate it. Okay. Next question. With OpenShift Container Platform, OVN, is it possible to take an online backup of a guest VM?
So I guess that depends on what you consider an online backup. So if it is a guest initiated, right, you're running a guest inside of the virtual machine, then that'll work exactly as you would expect.
Okay.
If you're wanting to do it at the hypervisor level, then we would rely on our third party, our ecosystem and of those backup vendors to be able to integrate with the native Kubernetes paradigm for, snapshot backup of persistent volume claims, because that's really what these disks are. Now, that being said, that ecosystem right now, there's not a lot of vendors who understand and integrate with Kubernetes. So that's an area where we're doing a lot of work and a lot of, how can we change that effectively? The other thing that I'll add is that with version 2.4, we don't yet support snapshots for virtual machines either. So on the roadmap is cold snapshots, so the VM being powered off to take the snapshot. And then eventually, being able to take live or hot, quote unquote, snapshots. And so the interesting part for this is because of how Kubernetes itself works. So when you go and so it's a PVC and it's backed by a PV that has most likely been satisfied by a CSI driver, right? A CSI provisioner. So if I have a CSI provisioner that supports snapshots, when I create that snapshot custom resource, when I say, hey, take a snapshot of this volume, it's non-deterministic when that happens. Basically, the object gets created, then we have to wait for the operator to be notified of that to get created, and then for it to do something to actually create the snapshot. And when that happens, we don't necessarily know. So we would have to stun the virtual machine for what could be many seconds before it actually takes the snapshot. So there's a lot of work going on in the background in order to make that easier, to make it faster, to make it more integrated into the traditional virtual machine, snapshotting paradigm that people are used to. So just know that, yes, we know, yes, we're working on it, and it doesn't work the way that you might think it does.
It's an actively developed project, right? And it's iterating as fast as it can, I feel like.
Yeah, and what I tell people is, we don't assume that we know or are aware of or are working every feature or capability. Always put in RFEs, right? Put in a BZ, put in an RFE. If you're a Red Hat customer, work with your account team so you can throw your weight behind that and help product management and engineering management prioritize those, because it is super important.
Yes, very much so. Thank you.
All right, so the last thing, kind of setup or prep work here. So notice that all three of my images here have finished downloading. The last thing that I'll bring up here is the GitHub page for containerized data importer. So quite simply, and here we can, all I did was go to github.com/kubevert. And if we search in the repository list here for data, you can see that there is the containerized data importer. And from here, if we go to doc, you can see that there's a whole bunch of documentation in here about how data volumes work and how to use them and all kinds of other stuff. So the page that I'm interested in today is kind of the core landing page for data volumes information. So you've heard me I've talked about data volumes a number of times, and I've also talked about PVCs and PVs a number of times. And the core thing to remember is that a data volume is a PVC with some additional services on top. So what does that actually mean? It means that when I create a data volume that says import this disk from this URL or this S3 endpoint or this container image or whatever it happens to be, essentially the CDI, the containerized data importer, will say, I need to create the persistent volume claim. When that volume claim is created, I'm going to, or a bound rather, I'm going to spin up the importer pod, I'm going to attach that PVC, and then I'm going to begin to stream that data down. When you manage data volumes separately, these can become pretty powerful. So things like if I were to go in and destroy the PV or PVC that is behind my data volume, the data volume operator will automatically recreate it. It will automatically re-import the data that originally sourced it. We can also leverage the data volume controller, right, CDI, in order to do things like clone disks. So if I have a PVC that has a source, a template disk, if you will, it will clone that in a couple of different ways, including, if it's available, it will use the cloning API or the cloning option for your persistent volume provisioner or storage class provisioner. So it is capable of doing smart clones in that respect, so long as they are CSI compliant. All right, so I'm going to come back over here. I'm more or less going to go in order with these and talk about them, except for Pixie. Pixie is very straightforward. It's Pixie. Basically, the only caveat here is OpenShift Virtualization doesn't provide any of the Pixie infrastructure. So there's no DHCP, there's no TFTP, there's none of that.
You got to build that now.
Yeah, you're effectively connecting it to a network that has all of those Pixie services enabled and letting it go. This is also the only option that is diskless, so if you wanted to have a completely ephemeral diskless boot of your virtual machine, you can do it with Pixie. So let's talk about URL. So effectively, to do a URL disk load or load a disk from a URL, rather, we need to host it on a web server. Pretty straightforward. So in my instance, and let's look at our downloads here. So we've got our various images here. I'm going to move star.qcow2 and move our ISO as well. And then I'll get rid of the duplicate one of these Fedora.
Oh, so much disk space wasted.
All right. I know it's all 300 megabytes or something like that. All right. So I have my two QCOW images. I hit the button on my mouse. So I have the two QCOW images here, one for Fedora, one for RHEL 8.2, and then I have an ISO image. So for URL, again, we're just going to host these. We're just going to put them onto a web server. So I'm going to SCP one of these over to my web server, which is running, if I can type, which is running over on my very convenient helper node. Thank you, Christian.
Yes, the Christian helper node, always the best.
So you can see I have a couple of images already here. I'm going to rename one of these just so that we can see when we pull it that it's coming from the one that I just uploaded there. So SCP. All right, so very simple secure copy commands of our Fedora 32 QCOW, and then I'm going to dump it into var www.html images as stream.iso. If I come over here and refresh our page, we now see our stream.io because I fat fingered my device name. Fortunately, I have an SSH session. Remember what I said about not talking and typing at the same time?
Yeah, like yeah.
Sometimes I'll start saying what I'm typing or typing what I'm saying instead of what I'm. Yeah, it's just not a good combination for me.
Rough.
All right, so now we can refresh this. Now we can see that we have our stream.iso already uploaded inside of there. And from here, I can go in and very simply use that URL. So copy link location. We will paste it in here. So Fedora HTTP. We will let this know that it is Fedora 31. It's a small image. Again, t-shirt flavoring. I think small is 1 CPU and 2 gigabytes of RAM. And just a simple desktop. After that, we'll just ignore most of these things. We'll accept the defaults. So networking, it'll use the masquerade network, which will put it onto, or the pod network, which will put it onto the network, the SDN that is being used by all of the other pods.
Mm-hmm.
And Andrew, on that disk image there, is 10 gigabytes enough?
It should be for Fedora. We can expand it if we want. I'm looking for my the usual. Come on.
If you just go back to your terminal and just do QEMU image info on that disk, it'll show you the size.
Yeah, I was looking for my the usual cloud init that I use. Let's go back. We'll adjust this. Thank you for highlighting that. So one other thing, or a couple of other things that have changed here. One, I can highlight or I can select my storage class specifically, and I can set these options directly from inside of here. So for example, if I was using a block storage device and wanted to pass it through directly as a block storage device, I can do that from directly here, as well as change the access mode if I see fit. So there are defaults associated with these, which we'll look at. I can show those in just a second. They're controlled in a config map. So if you don't specify anything for these, it will automatically inherit and it will use those values that are specified in the defaults file. So what I was just digging for a moment ago was this, it's like 30 characters that I just can never remember how to type. And all I'm doing here is creating the world's most simple cloud init to set a password for the default user. So Fedora, that's literally Fedora, and then setting it so that I don't have to change it as soon as I log in. So this just makes it easy to access that particular server. We don't want to attach a CD-ROM at this point. We'll talk about that in a few moments. And then we'll create our virtual machine. So if you've seen me do this before, you'll know that at this point, we should expect to see an importer pod that's running that is going to be pulling that disk from the HTTP server that we specified. If I had to guess, this is waiting to pull the, yep. So it bound the volume. Now it's assigned it. Now it should be pulling the image here. So if we're looking through these, it was waiting for the volume to be created and bound to the PVC. Once that was done, it scheduled the pod and then it pulled the image in. We can see it's now running. And if we look at the logs here, it is pulling that image from our particular host. So that'll take a couple of minutes because slow network, even though it's a small image. But pretty straightforward. So if we look at our storage down here, we see our PVC. We see it is backed by a PV. Now, what we can't see here is the data volume. So if I do a very simple OC get DV, you can see exactly the status of that particular data volume, as well as get details about it.
Nice.
And if we do an output into something that is more verbose, you can see very straightforward standards definition. Create a PV that is read write many, 20 gigabytes in size from this storage class, and then pull data using an HTTP endpoint from here. So that's all we're telling that particular data volume. And we can see that, oops, come back over here to our pods. So it's still running there. If I were to OC-get DV, we can see that it reports the status here. I believe if you do a logs on that, it'll probably be gone by the time I finish typing this. Yeah, it's gone.
Bye.
So I didn't go fast enough.
The logs will actually show at the end that disk image being resized to the size in which Andrew suggested. So the image is probably expecting 10 gig, but it finds a 20 gig container, and it'll just resize to fill.
Yep. Yeah. So it's another convenient thing about the DataVolume operator is it will resize the underlying image from whatever it is or wherever it was to whatever the size of the PV is. And then we rely on the guest OS at that point to then resize its file systems. So in the case of Fedora, RHEL, etc., Cloud Init is there, and Cloud Init will automatically notice the new size of the disk and resize those file systems automatically. If you're using something else or if you create your own disk, you would just have to take that into account. All right. So our data volume has been created, which means that our VM over here is now ready to go. I can very quickly turn that guy on just to let it run for a few minutes. Hopefully everything is working in this environment. I just stood it up last night. I've only tested it once, so.
Only once?
Only once.
Well,
there we go.
Lord knows we like to break things on this channel.
And if you're really fast, if you look at the boot logs after it's installed, you can see where Cloud Init notices that the disk needs to be resized and takes action based on that.
Nice.
Yeah, talking about live demos, if anyone remembers my first one where my box completely went out of memory, and that's the joys of nested virtualization right there.
Yes.
Yeah, I'm hoping mine might be borderline. We'll have to see. So the mouse disappears when I go into the VNC session, but you can see here to the right of my mouse that ETH0 is assigned an IP on 10.0.2.2, which is the pod network for whatever host it's running on, worker 0.
Nice.
Okay, so that addresses the URL. Very much the simplest of all of them, right? Really straightforward of literally put your QCOW up onto or raw image file up onto an HTTP or HTTPS server, let it pull that disk in. If I were to, again, destroy that PV or PVC that backs the data volume, it'll automatically re-import that data for us. And I'll show that here in a few seconds. So the second one that I want to show is going to be the container image. So container images are helpful in a couple of different ways. They're really good for providing really any disk, not necessarily an operating system disk. So what do I mean by that? So I'm going to demo taking an operating system disk and putting it into a container image and then pushing that up to a registry. But really, you can take any QCOW, any raw image file and put it into that container. And why is this useful? Well, maybe I have my application code published into that disk, and then I can simply update it inside of my registry. And then every time my VM boots, it pulls that new container image and then attaches that disk into the virtual machine. So it's yet another way of publishing an application to the VM or providing really any other arbitrary data. Maybe I have some sort of automation or other secret data, anything that I need to get into my virtual machine. Just keep in mind that it is treated like any other container disk in that it is ephemeral. So, or any other container image rather. So when it gets pulled down, when we instantiate it, it'll create that copy on write layer on top. That's where all of the writes happen inside of, or while the pod is running. When that pod is terminated, that copy on write layer goes away. So just keep that in mind. So creating these is super easy. So all I'm going to do is create a Docker file. And first I'm going to copy this because we will need that name. And all I'm doing is from scratch and then adding my file name into /disk. So that's really all there is to it. So from scratch means it's a completely empty image. I'm going to add this QCow image. It's going to go into a folder named disk inside of that particular image. That is literally all it is when we create a container image. Whatever that disk is, I'm going to add it inside of there. So we'll do a podman build. So I'm going to give it a super easy name, just stream, because we're streaming, and this is the Fedora 32 image. And dot. So we will, from scratch, add that image. This will take a second or two because it is a couple hundred megabytes. Or actually, I guess it's a little over a gig now.
Yeah.
I keep forgetting that the size of the image went up. It was, I think, 800 or 900 megabytes, and now it's 1.1 gigabytes.
Oleg in chat mentions, I thought it would be like kernel and init RAM FS. No, it's just disk.
Fortunately, yeah, fortunately, it's easier than that.
Yeah, no, it's actually it's kind of nice, right? Like you think it would be more complex, but no, it's kind of, we've pulled all away that glue and abstraction and made it very simple. The hardest part is just committing the image.
Yeah, or dealing with this obnoxious size of the images.
Yeah,
sometimes it can be, something Windows and tens of gigabytes.
Yes, I wouldn't know anything about that.
Yeah. All right, so we have our image. I think I need to do login to quay.io.
Wait, how'd you push it? Oh, you haven't pushed it yet. Never mind.
Let's see if I remember my username and password here. There we go. All right, so now I can just do a podman push of the image that we created. I always forget that you have to do Control-Shift-C and Control-Shift-V.
Mm-hmm. Yeah.
All right, so now we wait for my extremely slow internet to push up our 1.1 gigabytes, and it should be ready to go. So normally I have a, and I think you saw in our team chat, I was asking about creating a local registry instance.
Mm-hmm.
So normally I use a local registry instance. It's just easier to show that you can do this with any registry anywhere.
Right.
Hopefully any quay.io guys that are watching aren't cringing at me consuming
you, right? Yeah.
Rhys, in the UK there, is it quay or is it key? I think the Aussies say
it's
key.
Definitely key. I'm sorry, but it always gets me when you say quay. Key.
I don't know where that comes from. I really don't.
No
it's
idea.
Like a dock, right? Like a harbor, but yeah, where you go and dock your boats.
Okay, makes sense.
Yeah.
All right.
I think.
Well, it's I think VMware has harbor.
Rhys, I'm gonna put you on the spot here, and if you're looking at the Twitch chat, you know what I'm about to ask you.
Okay.
If you want to look at the Twitch chat and answer the question, you can.
I have it in the background somewhere.
Okay. Could this be a candidate to replace Rev?
I would say over the long term.
Long
sure.
term, yeah.
The future of virtualization is incredibly strong from Red Hat, and there are different solutions for different use cases. So when we look at Rev today, it's for traditional virtualization or enterprise virtualization where there are specific requirements. For example, the applications that you run on top rely on the underlying infrastructure for availability, dynamic resource allocation, et cetera, et cetera. OpenShift Virtualization is our first attempt at providing a single platform for both container or containerized and virtualized workloads through a single platform, single API, single storage, networking infrastructure, and so on. But whilst Andrew is showing lots of wonderful features, it cannot take over from all of the use cases and scenarios that Rev can satisfy today.
Right.
It's going to take us some time, right?
Yeah.
I've been at Red Hat 11 years now, and Rev has always been a thing in that time. And it's taken us, considerable amount of time for it to get to the point where it has all of those features. I'm not saying it's going to take all of that time for OpenShift virtualization to get there, because again, we're building it on top of all of the same infrastructure, but it takes time to reach maturity.
Mm-hmm. Right.
Yeah.
And like the OpenShift virtualization use case right now it's I think designed around those people that are like, we just need to get on a new platform. We've got to lift and shift these images in. We have no other choice, right? Like we have to do something with these VMs. We can't decouple them. We can't containerize them. We can't do anything. Okay, here we go. Here's the answer to your problems. And we're, evolving from there, basically, right? Like we're thinking about your transition from your traditional infrastructure in your data center to a cloud native kind of environment, and thinking of, oh yeah, there's going to be stuff that's not going to be able to be containerized that people still have to run.
Exactly. And I think OpenShift virtualization presents itself as a great platform to consider modernizing those applications.
Mm-hmm.
And having that one platform for both side by side is incredibly lucrative. We recognize that virtualization isn't going away anytime soon. I think a lot of organizations have a desire to move or modernize a lot of their applications to containers, but that takes a considerable amount of time. Some applications may never be containerized. And so I think the desire really, and certainly the trend that we're trying to address, is that single platform for both. And you can optionally use that platform to look at modernizing through the same APIs.
Yeah, I'll pile on to what you said, Rhys, of OpenShift virtualization is less about the workload per se. Of course, you want to make sure that it fits within the constraints and capabilities of OpenShift virtualization. So things like snapshots, right, as we just said, don't work the way that you would expect them to, and won't in the near term. But beyond that, it's less about the workload, the application, and more about how you're consuming it and how you're managing it. If your application or your application team is already doing the majority of their deployments, the CI/CD pipeline, all these other things, leveraging Kubernetes and the Kubernetes API, then bringing virtual machines underneath that same paradigm can sometimes make a lot of sense, right? It eliminates another pillar, another vertical inside of the organization that they have to deal with. As far as long-term, whether or not it'll become a replacement for Red Hat virtualization, that's for product management to figure out, not for me.
Right.
Right. But I mean, Rev's lifecycle goes through 2026. So, I mean, it's not going away anytime soon.
It's not going away. I mean, that's for sure, right? Like the life cycle is there. It's not going anywhere.
Speaking of which, Red Hat Virtualization 4.4 GA today.
Today, right? Like we just released the product today.
Yeah,
so it's not going away anytime soon.
So yeah, 6 years minimum. All right. So while we were chatting, the only thing I did here was I logged into my Quay account or Key account if you're Aussie or British, and changed the newly created repository. Remember, I called it /stream. So I just changed that to being public. So that way I don't have to add my pull key into OpenShift or anything like that. It'll just work. So, and then just to verify, we have so I'm in the /stream, and we have our Fedora 32 tag. So at this point, I can come back over here. Come back over here and create a virtual machine. So first, let's stop this guy.
See, that's probably where I went wrong. I don't remember stopping my virtual machines. That's why I ran out of memory.
Mm-hmm. Yeah. So I am going to delete the disks. This is another thing that was added with 2.4 is the ability to separate. Previously, if you created the data volume as a data volume template, so real quick, you can create data volumes separately, or you can define them as a part of the virtual machine as well. So you can see this data volume template. So every time you instantiate a new virtual machine using this YAML, it'll create a new data volume based on that template. So before, if it was created as a data volume template and you deleted the VM, it would also take the data volume with it automatically. Now we have the option here of deleting it or not deleting it, as the case may be. And if I were to check our persistent volume claims, you can see it very conveniently cleaned up after us. So let's do the same thing. We'll name this one Registry Fedora. I'm going to pull this one, come on, from a container. So this is just the tag that we provided over here on the command line here. Same as before. We will provide the operating system and other details. Here, I'll customize this one. So 2 gigabytes of RAM, 2 CPUs, and it is desktop. So if you don't remember, so the workload profile here, which is this is something that I first saw with Red Hat virtualization. I don't know if it's an OpenStack as well or not, but this effectively applies pre-tuning to the KVM or the QEMU process that's started for the virtual machine. So things like if I select high performance, it'll automatically define IO threads and associate them with the pod or with the virtual machine. There's a bunch of other things. They're all defined in the documentation as to what each one of these does with that particular process. Just to change it up a little, we'll attach this one to an external network, so directly. So in my lab, this will connect it to a 192.168.14/24 subnet.
And that's just, by the looks of things, it's just an external bridge network where you've just got your hypervisors or your OpenShift nodes that have access to a specific network. Okay.
Correct. So it's so my nodes have a second network interface that is connected directly to that interface. That being said, when you deploy OpenShift virtualization, it includes the enum state operator, which I absolutely adore because it simplifies that day 2 network config for the nodes dramatically. Right, create the NNCP, the network configuration plan, node network configuration plan. Hey, it's basically the enum state operator or the enum state. Why is my brain not remembering what this is? It's using enum states and YAML in order to define what network manager should have the network interfaces look like. Hopefully that makes sense. And I can show, if you think it's valuable, I can certainly show what that looks like inside of my lab as well. So back over here, because we're using a container for this, you'll notice that I don't have all of the same options that I did before. Basically, I can't change the size. You see the size is dynamic because it's going to be based off of the size of that copy on write file system, which is by default the same as the underlying disk. So there's no defining the size. There's no selecting a storage class. It's not a PVC, so there's no storage class associated with it. So really the only thing I can change here besides the name is what type of interface I want to use to connect. And there's no reason to change that from virt.io here. So I can add a second disk if I so choose. So if I wanted to create, for example, an empty disk here, we'll do that real quick, a 10 gigabyte empty disk. Same thing, we can define all of the different characteristics. So what we should end up with here is 2 disks associated with our virtual machine. One of them being that container disk, the other one being our additional blank or empty disk. Still not going to do a CD-ROM, that's coming up. And then we can go ahead and launch our virtual machine. So one thing to note here, because it's a container image, there's no need to do a import. Basically, this importer is creating, so see how it's disk 0? So this is creating our blank disk is what it's doing. It's not importing the disk from the container registry or anything like that. You can see it just fired up and then turned right back off. And now it's gone. So that's all that was doing. That was because I added the second blank disk, not because it's using a container image for our base OS. So at this point, if I start our virtual machine, what we're going to see is it will get scheduled, and then we will have to wait for the node to pull down our container image. So if we go to events, so it's a little larger, you can see container image already present. So that's the virt launcher. And down here is polling image quay.io/ansulliv/stream tag fedora32 or f32. So that'll take it a moment. Again, we're pulling 300-ish megabytes across the internet. And what we should see at the end of that is our virtual machine turn on. So a couple of things to talk about here. So since we had created a second disk on our virtual machine, one, you can see that there's a DataVolume template that is source blank. So that was where we saw that importer pod start up. Essentially what it did in the background there was created an empty 10 gigabytes disk inside of that PVC at the /disk location. The other thing that we see here is for disks, you can see that I have a couple of different disks. So first is root disk. The second one is disk 0. And then we have our cloud init disk. So remember, root disk is the container image disk. Disk 0 is our blank secondary disk. And then the cloud init disk is, well, the cloud init that we provided. And we can see down here underneath volumes, the definitions for each one of those. So root disk is defined as this container image. Disk 0 is defined as a data volume with this particular name. And if I let's clear this, if I get my data volumes, you can see our registry Fedora disk 0 as being created. And then last but not least is our cloud init disk that was created here. So just like with the others, and I don't know why, sometimes my interface freezes up, and it does this for like 30 seconds.
I think it's your browser, because it was doing that when you were doing your searches earlier. I don't think that's the console. I think it's.
I bet it is
your system.
Firefox.
How long has that Firefox tab been open?
All right, so we can see our virtual machine is already started here. So I'm going to log in. No, I say I'm going to log in, but apparently I don't remember either the user or the password.
You've got a RHEL image here, not a Fedora one.
Oh, you're right, I do.
I think when you created the F32 disk image, you actually pulled in the RHEL image instead. So just try root Red Hat. Oh yeah, all that.
Yep, cloud user. Yeah, so that's my own fault of getting my images mixed up. If we do a quick check of our IP address, you can see again to the right of my mouse cursor here, 14.136, which makes it a publicly accessible image as well. So I can come here. And we can see that it's there. All right, so with this one, let's take a look at a couple of things here. So first, let's go to our pod. So remember that everything in Kubernetes is a pod. Our virtual machines are no exception. There is a virt launcher pod associated with each one. And when we look at this pod, I can go to the terminal conveniently through the GUI, and we have our different disks available here. So if I look at the processes that are inside of here, you can see we have our QEMU KVM disk that's inside, or disk process that's running inside of here. This represents our running virtual machine.
And again, that's kind of the important thing, right? We're just running the same binaries or the same processes that our other virtualization and private cloud software uses. So really what we're doing with OpenShift Virtualization is teaching it how to define and manage the lifecycle of virtual machines, not starting from scratch.
Exactly. So the other thing that we want to look at, and you see, if you saw, I just did a quick mount command. So all I did was mount because I want to see where my PVC has been mounted at. So you can see this is our PVC definition. So 02 F420. If I come back over here to our persistent volumes, you see F420. Come back to this guy. So it is mounted on this particular path. And you can see that if we were to come here, We have our disk 0. Inside of there is our disk.img. So this is our 10 gigabyte blank disk. So this is the behind the scenes of what any disk being mounted into that virtual machine looks like. So in this instance, it's our secondary disk. If it were our primary disk, it would be handled exactly the same way. If we had more than one disk mounted this way, they would all be seen inside of here, and then they're attached by libvirt and QEMU. So if we switch back to our virtual machine now, in our console, what we should see if we do an ls block is our disk that's inside of here. So again, my mouse disappears, but we have VDA. So VDA is our container image disk. This is the one that has the operating system inside of it. We have VDB, that's our 10 gigabyte drive that is attached to the second one. And we have VDC. So VDC would be our cloud init disk that was attached in order to pass that information. And if I do a quick check, VDB is not mounted anywhere, but I think VDC, oh, maybe it's not. I thought VDC might continue to mount, but I think it might also be unmounted by Cloud Init. I don't know if you know what happens there, Rhys.
I'm sorry, I was trying to find the answer for Ahmed on the chat. What was the question?
No worries. Do you know what happens? Do you know if the Cloud Init disk, the temporary disk, stays mounted after Cloud Init is done, or does it unmount it? I think it unmounts it.
I don't know. If it's not shown there as mounted, then yeah, it probably unmounts it. It's not showing as it being mounted.
No, it shows present but not mounted.
Yeah.
So all I'm doing, I'm just going to put a quick partition on this. If you can see, the first time it failed because I was trying to do it as the cloud user, not as root. So new partition, primary partition, partition 1, start at the beginning, end at the end, and then we will write it out. Put an ext4 file system on there. And we have our newly attached disk. So you can see it is a 9.8 gigabyte size after formatting and everything else. So conversion between, power of 2 and power of 10. And that's it. That's our disk. So just keep in mind, if you're adding secondary devices to virtual machines, that you do from inside of the guest OS have to manage that attachment. So it's not like a traditional pod or container where you say attach this PVC at this mount path. It's going to be attached as a disk device. So you saw dev VDB in this instance, based on the order that they're defined in the VM YAML. So you can change that order, of course. You can put them in whatever order you want. You can also have logic that goes in and checks and empirically determines which disk is which if you expect it could change for any reason. And you see I can write on here, of course. So just creating a quick bit of sample data inside of there because I also want to take this disk and I'm going to reuse it. So let's exit out of here. We will go ahead and turn off this virtual machine. And we will destroy this virtual machine. Oops. Did you see what I did there? I was going to prove that the disks do persane, and I didn't uncheck the box that says retain disks. That's what I get for clicking too fast. So when we come back, we should see our no persistent volumes found. However, this gives us a good opportunity to define a data volume by hand. So what I'll do here is simply from GitHub, I'm going to copy and paste our sample image here. And paste it inside of here. So all I'm doing here, example blank DV, I'm not even going to change the name. Read write many access mode because I'm using NFS storage class. And I think I need to add in the storage class. I'm trying to remember where that goes in the definition because I can never remember.
And are you just using the basic NFS, no provisioner, or do you have a dynamic provisioner in there?
It's it is a dynamic provisioner, but it's the one where it's one NFS mount that gets mounted and has the PVCs created as folders inside of there. And
Okay,
that's what
cool.
it actually mounts. Yeah, I can never remember the name of it. Just to make sure I'm remembering names correctly. Storage class. Yep, managed NFS storage. Okay. Oh, so one thing to note, the upstream is an API version ahead. It's beta instead of alpha. So we can see our DV has now been created. If I switch back over here, our persistent volume claim was created by the containerized data importer. If we check it again, it succeeded because it didn't actually have to import anything. Remember, I created it as a blank one. So see, it is blank and it is 1 gigabyte in size. So now we can do a couple of different things. So one, up on our virtualization, we can create a new virtual machine just as we did before. We can use the same container and image. Actually, do we want to actually use a Fedora image this time or not? I do have one in a different repo.
Well, if you deploy from that container image, you are going to get RHEL.
All right. Oh, another thing to note. So notice my guest operating systems down here. So these will change based off of which source we select here. So there should be another. Well, I say that. Yes, cancel. So we have a bunch of operating systems available here. But if I select a source, it changes what's available inside of here based on there, among other things. I don't know if any of these are actually changing. They don't seem to be. It should be changing, I promise. Real 8. All right. So I'm not going to adjust the network this time, but I will attach our existing disk. So because I created that persistent volume independently, I can attach it as a standalone disk, and I simply select the persistent volume claim that I want to use. And then this name represents the name that it will be attached to the virtual machine with, not the name of the persistent volume claim. Do the same thing with our cloud init. Remember, this is a container image, so it is ephemeral. And then we'll go ahead and start this guy. I haven't been paying attention to chat. I trust you all are paying attention in chat there. All right, that didn't take long at all because it probably got scheduled to the same worker that already has the image. And we can see it is already deploying or already up and running. Chris Short, I think I see your mouth moving, but you're on mute if you're trying
Sorry,
to talk to us.
Rhys has got the question that I was trying to ask. My bad. But yes, the question is there a way how to say OCP only deploy VMs on nodes with label worker VM, for example?
Yes.
Rhys said, yeah. Rhys says he's 99% sure. I'm pretty sure it's 100% sure that you can say like only go to these like nodes.
Yep. Yeah, you can apply node selectors just like you can with any other pod.
Mm. Yeah, I mean, basically, it's treating the VM like a pod at this point. So it's Kubernetes and OpenShift once you get past the disk image, right? Like,
yep.
Basically. Yeah, it's just a VM in a pod.
Yeah.
I mean, everything is a pod.
Everything
is running in a pod. Yeah.
Yeah.
All I'm doing at this point is redoing the steps for formatting the drive.
You mistyped sudo.
How?
Oh, you're right, I did. So the issue is permissions.
Always.
What do you mean sudo is not found?
Oh, dang.
It's because I did dash and not dash I. It's su dash or sudo dash I, and I mixed them or combined them. So the issue is when we look at ls-ld dot, you can see it's owned by root and only has user writable for /mnt, which is why the cloud user account cannot write data to it. So if I were to do a change mod to so now it's world writable, and if I go back to my regular user and come up here to do this again, now it works just fine. Permissions. It's almost like they're a necessary thing.
I like how you made it world writable.
you know.
Just cause.
Next thing you're going to do is turn SE Linux off, aren't you?
Yeah.
It's I thought that was step one for everyone.
Oh. Damn,
and the firewall.
Just cuss.
And the firewall.
That's right.
All right. So /mnt is where I mounted the secondary disk. We just created some test data. You can see I put the date in there, 2:14 Eastern time, 2:14 p.m. Eastern time. And then just for giggles, we'll do the same thing in the home directory of this cloud user. And if we were to shut down, actually, I'll do it from here. So if we stop our virtual machine and then start it back up, we should expect that data to go away. Right. All right, so I'll let that turn back on. So the last thing that we want to look at here for our sources is the disk. So when we create or when we use a URL, if the containerized data importer reaches out to that URL and it pulls in a disk image, and it adds that disk image into this same disk exactly like any other PVC. So how can I pre-create that disk? If I have one that I want to use for a virtual machine, maybe I want to create a template, PVC, something like that. And there's a couple of different ways that you can do that. So the way that I'm going to do it is with virt control. So you can use a data volume. So just like I defined a data volume here, just like we saw with the data volume templates with the other one, of specify the source as being, for example, a URL, tell it to pull that in. And then when you create the data volume from the CLI, it goes through the exact same process. But with virt control, which is the CLI command line, right, for OpenShift virtualization, I have a number of different things available to me, including image upload. So to get virt control, there's a couple of different ways. If you're using a rel box, and I honestly don't remember the last time I used a rel box for my desktop, there is an RPM package, right? So you can add the repo and then just do a yum or a DNF install. For me personally, most of the time, I just go to the kubevirt's GitHub page. It's just github.com/kubevirt/kubevirts. And then if we go to the releases here, and you can see down here, we have virt control for each one of the operating systems. So Mac OS, Linux, and Windows conveniently. So all I've done, I just grabbed virt control, and I have a number of things available to me here. So first, I can do virt control, get VM. No, control. Now I can never remember the other commands that we use here. So OC get VM. So we have our Red Hat virtualization, or excuse me, Red Hat Enterprise Linux VM. So I can do virtctl start. And it'll start that, hopefully. Oh, it's already running. So virt stop. So I can start and stop virtual machines inside of here. You can see I can also do things like pause them. I can trigger a migration. So lots of interesting things that can be done through the command lines. Remember that this is just an interface to the API. All of these same things can be done by creating API objects. So if I were to do, if I look at my CRDs for kubevirt for OpenShift virtualization, there is a virtual machine instance migration object inside of here. So if I were to do a explain, I think explain will work on these. It's supposed to work on these. Nope, they must not have populated the whatever that reads. Normally OC explain you can use to see exactly what fields go into that CRD. I don't know why they're not there with kubevirts. Anyways, what I'm getting at here is all of these are just API commands that have been put into a CLI interface in order to interact with it. So you can do all of these things just as well by creating, using kubectl or OC. You can do all of those same things, or you can use virt control to do that. So image upload is the command that we want to use. And I'm basically going to copy one of these and use that. So you can see all I'm doing is saying virt control image upload to a data volume with this name, this size, from this particular disk image that I'm going to use here. Now you can also specify, as you can see down here, I can also tell it to pull that in from, for example, a URL if I wanted to. This one I'm going to actually try and make sure is a Fedora image, by the way.
Mage path. Yeah. It's the path you take in World of Warcraft. Yeah.
All right. So virt control image upload, create a data volume named dv-fedora that is 20 gigabytes in size. Because I'm not specifying the storage class, it will inherit the default storage class. And then we wanted to upload this particular image. If we hit go, you can see it created the data volume, waiting for the PVC to be created. We can switch over to our GUI and we can see all of these things happening. So here's our DV Fedora volume. So now it's waiting on the pod to be ready. So if we come back up here to our pods, we should see an upload pod get created. And in the background here, it either failed, signed by unknown authority. Figures.
Oh, you got to do the insecure flag, maybe?
Yep.
Yeah.
And there we go. So now we're uploading that image into that volume. Again, if I can switch over here and look at the logs, and you can see it's doing its thing. And our upload has finished over here. We can see the logs saying that it's validating, should say that it's expanding the disk to match the size of the persistent volume claim. We'll let that go for just a second. Well, come on.
Yep, run out of disk space if you.
Yeah.
I don't think so. But that's a good question.
Well, it's validating.
I see one of them complaining about being 85% full. I should probably check on that. Oh, that was from July 18th. Yeah, we're fine.
Since cleared.
Well, it hasn't failed yet, so I'm guessing we're okay now.
Yeah. That's just taking a while.
So while it's finishing up, just a few things. So remember, I didn't specify the storage class name, right? So it went with the default. So storage classes, we can see this is the default. If I don't have a default created, I would expect it to fail. Oh, there, it finally completed. I would expect this to fail without specifying one. So I mentioned a few moments ago how we can customize the type of volume that is created. So read write once, read write many, as a part of the data volume, the CDI defaults. So where that is done is in a config map. So if I switch over to my CNV namespace, I have a kubevert storage class defaults object inside of here. And if I look at that object, you can see down here in the data section, for each one of my storage classes, I can define what I want the access mode and the volume mode to be. If there is no, basically, if the storage class is not defined in this file, then it will inherit whatever is set here for access mode and volume mode. So in this way, I can customize each one of my storage classes to provide, or to let the data volume importer know which type of storage it is and which type of volume I want associated with that. So this is convenient in particular because, see, the default is read write once. If my default storage class is NFS, then I probably want read write many to be able to do things like live migration. Remember, live migration needs read write many PVCs. So this is how we can change that, or change the defaults. Remember, file system is also the defaults. If you want to use block, so you pass a block device, block PVC directly attached to that virtual machine, you can change that here as well. All right, back up here. So we can create our virtual machine. Call that one data volume Fedora. We'll select a disk here because it's Fedora 31. Again, I'm not going to change our pod networking for this particular one. So here, things are a little bit different. So I want to add a disk, and in this time, I want to use an existing disk named dv-fedora. So we'll go ahead and add that, and then we must specify that disk as being bootable. Same script as always. And we'll create our virtual machine. So because we already imported the disk, right, we just saw it go through that process. We don't need to wait for it to do that import again. We can go ahead and fire up our virtual machine, and it should start right away, or very nearly right away. There we go. And now our virtual machine is booting. So again, super easy, creating a data volume to import that data for us. You can pre-stage a whole bunch of those if you wanted. So, hey, I need to create 10 virtual machines, create 10 data volumes and let them all import. Alternatively, and what we'll look at next is cloning that data volume in order to create effectively what is a template volume. All right, we don't need to wait for this guy to boot. I'm going to go ahead and stop you. And I'm going to go ahead and delete you. Notice in this one that because it was a disk volume, it was decoupled. So I need to come down here to my persistent volume claims. So remember how I said that if I deleted the persistent volume claim underneath the DV, that it'll get recreated? We're about to test that. So there, it deleted it and then it recreated it immediately. And if I come back here and do OC get DV, you can see that it is back in the upload scheduled phase. And if we keep watching this guy, it should go back into the, we should have a pod. So upload DV Fedora. And if we go to the logs, we can see this guy. This one will probably fail, yeah, because it was an upload instead of a URL get. So it's waiting for me to send an upload into it. I don't know if this will oh, it does work exactly as you would expect it to. What do you know?
Shocking.
Engineers are way smarter than me. So essentially all I've done at this point is reset that disk. So because I had booted it the first time, Cloud Init did its thing. It set the host name, it set the password and all of that other stuff. So by deleting it and allowing the data volume, containerized data importer through the data volume mechanism to recreate it, it's now back to being a quote unquote fresh template disk. So we'll let that do its thing for a moment while we go ahead and define our next virtual machine. So this time I'm going to use a disk source as well. It's still going to be Fedora 31. It's still a desktop machine, again, not changing our network. And this time I want to attach a cloned disk. So for this one, we need to specify where the source disk is at. We're going to use the one that's in the same namespace as our virtual machine. And we want to specify the source persistent volume claim. So effectively from here, it will duplicate all of these other things based on what's already there. And from here, we can add that guy, set it as disk 0. Let's check over here. We're still going, so I won't hit the review and create yet. There it goes. So same as before. Oops.
You did the control shift.
I did. You noticed that.
I do it all the time, man.
So we'll paste in our Cloud Init and review and create our virtual machine. So now when we go look at our virtual machine details, status is off. And if we look at our pods, we have our CDI pod running yet again. So this one, so sorry for jumping around a little bit here. If we look at our persistent volume claims, you can see that we have our template Fedora disk 0. So this is the one that we just created. If we look at our pods, we can see that this guy is probably still scheduling. And down here we have our volume. So if I had to guess, it's waiting. Yes, sir.
Sorry to talk over you. Only because I haven't done this particular operation. What would happen if the volume that I was trying to clone was already attached to and running on a virtual machine?
Oh,
can it freeze the file system, allow it to be cloned?
I don't know. I know who to ask.
Sure.
Alexander.
Yeah.
If you want to ping him on GChat or something. All right. So our pod is running here. Check our logs. It should go through and do its thing here, I hope.
Hmm.
This is one, I didn't pre-test this scenario, so if it blows up, it's not my fault. I claim no responsibility. No. Is there any questions in the chat? I know Rhys has been on fire in chat.
Rhys has been on fire in chat. No, there's not any questions. We are curious how you say kubectl. How do you say that?
You'll notice that I switch between kubectl and kubectl and kubectl, mostly so because I'm an equal opportunity offender.
There you go. I like it.
Whichever one you like, I will get around to it eventually and then move off again.
I love it. I love it.
Fantastic.
Yes. kubectl, kubectl. I've been known to say all three.
Yeah. They all work. They're all my favorite children, just like my real children.
Wow. You put them up there on that level?
So yeah, with my children, I try to be nicer as you're all my favorite instead you're all of my least favorite. I dislike all of you equally.
Okay. Yeah, I dislike all my clusters equally. I like my children equally, though.
Yeah, there you go.
Yeah.
So cloned our disk, right? Template Fedora. So we can switch over here. We can see it's running, booting, doing its thing. If we wanted to, we can create another VM. I don't think I have capacity. I'm going to cause my cluster to fall over if I try and do this again. So I'm going to avoid that. But yeah, it booted exactly as we would expect it to do. Clone that data out. It happened pretty quickly. It's only a couple hundred megabytes, so I guess that's to be expected. But again, my storage class does not support the CSI clone operation. But if you had one, it would be able to take advantage of that.
Nice.
All right, so the last thing I want to do is use an ISO to load an operating system. Let's go back to our VMs here. We can leave those in place. So to do this, so remember I grabbed our rel ISO here. Now, actually, I don't think I want to use the rel ISO because it is gigantic. 8 gigabytes is a lot of waiting around and me tap dancing.
So I'm sorry.
Go ahead.
Whilst you're downloading that, and this is the benefit of having access to some amazing engineers. Alexander has already given me a reply to the cloning question. He essentially said that if you're using a read-write many, it'll allow the cloner pod to get access to that disk as well. But depending on the turnover of the file system on top, what you end up with on the clone volume may or may not be corrected.
So don't do this with a database.
Yeah. So if you use if you're using read write once, then obviously that clone pod won't be able to get access to the disk.
Yeah.
But read write many, it should allow you to do it. But yeah. If you're going to do it properly on a server you really want to keep and you're using read write many, you either want to turn that VM off or freeze the file system inside of the guest and then run your clone operation. Then you should be good to go.
Nice.
All right. So all I'm doing here is pulling down the most recent version of the CentOS minimal ISO because it's about 1.5 gigs in size as opposed to 8 gigabytes.
Golly. I remember when these things were hundreds of megs, like low hundreds.
Yeah. So it's funny. I was deploying Pi-hole the other day, and I deployed using Debian or Debian, depending on your preference for how hard the E is. So I can install a Debian minimal in like 256 megs of RAM, super small. Whereas rel 8, I think it's about 1 gig is what the small end of that happens to be.
Yeah.
So yeah, it's surprising how different each one is and all of that. I guess it's not surprising. That's why there's different distros, but
different variants of different distros. Yeah, totally.
All right, so we have our ISO disk here. What I want to do now is create a data volume. So just like I did before of virtctl image upload a data volume type. name CentOS. See, trying to type at the same time.
You can do it. You'll eventually get good at this.
Yeah, but the real question is, can I remember what the command that I need to use is? Oh, I cleared it. The answer to that is no. No, I cannot. And then I want just image path, size. All right. So we will upload our ISO image into that data volume. So the same as before, waits for the PVC to be created, attaches it to a pod. The pod then waits for our client to connect, and it then sends the data up. And while that is finishing, going about its merry way, because we don't need to sit and watch the percentage counter increase, I'm going to create our virtual machine. So real quickly, before I do this, however, there's a bit of a cart before the horse problem of when doing this through the wizards, when I go to add a disk, I need to have a disk that I can mark as bootable so the wizard will let me complete it. So this is going to look ugly, and it's just because of the way that things are. It should be fixed in the future. So what I've got here is, so my example blank PV is not big enough, so we'll have to fix that here in just a moment. All right, that guy's doing its thing. So what I want to do here is create a CentOS data volume, and this one I'm going to make as 20 gigabytes as well. So all I'm doing is creating a blank data volume, a blank disk, which is what I'm going to use to attach as the first disk, the bootable disk for our virtual machine temporarily. Again, this is a quirk in the GUI that it won't let us move past the disk screen without marking at least one of them as bootable. So create a virtual machine, I'll call this one CentOS. Our source is going to be a disk. CentOS 8, which is the same as RHEL 8. So again, I won't mess with the networking interfaces here. So remember, this is, I have to have some sort of disk here in order to move past. If I create a blank disk here, for whatever reason, it won't let me mark it as bootable. So I'm going to create a pre-existing disk, or use a pre-existing disk rather, of CentOS-DV, and we'll set that one as our bootable disk temporarily. So just like always, we'll use our, actually I don't need to do cloud init because we're installing from a CD. So here I will attach our ISO. So I can import these, right? I can specify it as a URL. If it does that, containerized data importer again will kick in. It will import that ISO image to a persistent volume claim and then attach that just like it does with a standard disk. Same thing with a container, right? I can use a container image for my ISO. This is another super convenient way of attaching those. So the reason why I tend to do it this way is because in my lab, remember it's a home lab, I'm limited on storage, etc. If I do the container option, it has to pull that image locally to the node, which if it's like a RHEL ISO, remember that's 8 gigabytes. And I think my base OS images or disk sizes are only like 80 gigabytes. So using the attached disk option to use a PVC means that it's hosted off of an external storage device, so I can save that particular capacity. So I'm going to attach my CentOS ISO persistent volume claim, and we'll keep the SATA interface, but if you really want to change it, you can. And then we're basically done with this particular step. So I've created my virtual machine. I've defined my virtual machine. And if we look at the YAML associated with it, you can see down here that I have this boot order option. So I can change the boot order associated with each one of those disks. So I can change it in the YAML if I want. I'm going to show using the GUI in order to do this. We see on the details screen, we have this nice boot order with a pencil next to it. I can add a source. I want the CD drive here, and then I'm going to move it up as being the first one that I want it to boot from. Click Save. And now when I turn on my virtual machine, what we should see here is our VM start and then boot to that ISO device. And that's exactly what we get. So I can select my image install. Wait for it to do its thing so we can get to the why can I not think of what the installer interface is called at the moment?
Anaconda.
And is it Anaconda that does the GUI part of the install?
I don't think so anymore.
Oh, it's me just showing my age.
It might be. It still might be Anaconda. I don't remember, to be honest with you.
It's not age, Rhys. It's maturity, showing you maturity.
Thanks. Thought that was the gray hair.
Hey, I have no room to talk.
Neither do I.
So speaking of age, we can tell how slow my infrastructure is here because it's taking its sweet time.
Well, you know, you've got a lot going on there.
Yeah, I'm afraid to look and see what it looks like at the moment. I'm having flashbacks to Rhys's. Yeah, the host is running at 85% memory. It's fine. It's fine. It's okay.
It'd be fine.
It'll be all right.
How much swap space have you got set up?
I don't know, actually.
Then I guess it depends on how fast your disks are.
Yeah. Just set a few random things inside of here, right? So automatic disk provisioning. So software selection. We'll do the minimal install. And that's good enough. Nobody steal my ultra secret, ultra secure password.
It's weak. I called you weak.
I know. So anyways, it's going through, it's loading. So this works with Windows as well. If you wanted to install Windows, which is super important, you can absolutely use this method. So the big thing that changes with Windows is it doesn't recognize or it doesn't have the VirtIO drivers out of the box. So fortunately, OpenShift Virtualization very nicely, and we can actually see this in action. So if I were to create a new virtual machine, and it doesn't matter what I select here, when I go to Windows, sure, it's medium. So we'll add one of these disks. Because what I want to show here is it's automatically going to attach the ISO for the VirtIO Win drivers. So you can see that this is coming from registry.redhat.io. You can, of course, pull that into your local registry. I'm sure you can rebuild it if you wanted to based on the Docker file that exists upstream. But it will pull that ISO in and it will attach it to the virtual machine. So when you go to do the Windows installation process, right, you'll click through the process and it'll ask what version of Windows you want to install. You know, do you want to do the one with or without a GUI? When you get to the next step where it's asking you what disk to install, if you chose the VirtIO bus type, there won't be any options there. Remember, the drivers aren't there unless you slipstream them in, which is well beyond my Windows administration capabilities. So you want to do an attach or a use disk and browse to this CD-ROM device, and then select it, and it will scan the disk and find the drivers relevant for your particular operating system. So select them, hit OK, the disk will appear, and then you continue with Windows installation just like always. So you want to, after the install is finished, you do want to use that same ISO again to install the integrations. So when you open that disk device, there'll be an executable file inside of there. Just execute that. It'll install all of the other drivers for everything else, all the other integrations with KVM for Windows after the fact. So Windows works great. I would say I'd test it, but Windows takes forever to install.
Yes. I would tell you I have a great image available on the internet, but it's not anymore.
Yeah.
I've been trying to figure out how that happened. I mean,
so
I'm just thinking maybe there's like a failed, like someone deployed a cluster somewhere and was
a lot of clusters is what I'm thinking.
Just one, and it was constantly pulling that image and was just failing, and then the pod would just get restarted and just pulled it again. I don't know.
I have no idea. And what we're talking about, folks, is last month I got a $2,700 AWS bill because I had uploaded a 13 gig SQL server with all the trimmings, right, all the drivers and everything else that needed to be used and installed to work on OpenShift Virt. And somehow it got out that this image was out there and someone used it to the tune of 31 terabytes. The image was only 13 gigs, so you do the math, how many times it was actually downloaded. But turns out, after the fact, that Cloudflare was sending partial gets to the bucket, and S3 was responding with full requests back, and Cloudflare was sending them full requests as partial gets as well. So that's part of the problem. I don't think that adds up to the tune of 30 terabytes, but yeah, something went horribly wrong there. And I'll pull up the article that I wrote about it, folks.
It must have been the thousands of desktops I deployed that month.
Well, I mean, the crazier thing is that there was no events on the calendar. There's nothing to explain the who, the how, the why it happened. No one's fessed up to it. Like, hey, I might have broken something, or hey, I downloaded this image a million times or something. So clearly something just went wrong. So yeah, don't know yet.
It makes me wonder. It makes me wonder how often that happens with, if you're paying 7 figures to AWS every month, or I'm sure Azure or Google or any of the others, would you even notice an extra $2,000?
No, you wouldn't. And that's totally the reason why, right? Like, to AWS, it's easier for them to refund the things that break, right? Like the bill was basically wiped out essentially in the end, thankfully. Thank you, AWS. Thank you, Corey Quinn, for helping me out. But like, yeah, for a normal enterprise, if you're spending $1 million a month at AWS or something like that, right? Like $2,000, you're not going to even notice. So the fact that this like data time bomb is sitting there is interesting to me. So needless to say, I'm looking for new CDNs, and I'm not uploading any 13 gig files to S3 anytime soon. Whatever.
I got nothing on that one.
Yeah. No, I mean, it was literally designed just to share real quick with Jafar, and it kind of persisted. And then I got asked a few more times for it, and it was like, I need to do something with this, and I didn't do something with it in time, and it bit me in the butt. So yeah, mind your personal projects in AWS, folks. Monitor them well.
So all I've done here is I restarted one of the other virtual machines. This is the one that is based on a container image, a registry image for RHEL 8. So what I want to do with this one is, I want to start something, say an HTTP service, and then expose that to the rest of the world. So to kind of close out the last process, right, we looked at how to create a virtual machine disk based off of a QCOW or a raw image and upload that into either via a URL, via a DataVolume, and uploading from the command line, how to put it into a container registry and use that, which is the instance that I'm using here. And then the same thing with an ISO, how to boot a VM from an ISO and then install the operating system from there. And I stopped that because it was taking forever. The only thing that you would want to do there is, particularly with Windows, so after the OS installs, right, install those secondary drivers and everything else, turn it off, and then remove those extra ISOs, those CD-ROM devices, and then restart it again. So remember, hot add doesn't work, or hot remove doesn't work. Neither one of them work with OpenShift Virtualization. So you have to turn off the VM in order to add and remove those disks.
Good to know.
So what I think here is I might have to register this guy. Maybe I should have used a CentOS image or a Fedora image, because I think I'm going to have to register it in order to be able to pull any images.
Well, it hides your password.
Yeah, but I also have to entitle it. So with the
you don't have an employee, sir?
Yeah.
Yeah, but you would have to expose that, I think.
We'll just create a new one.
All right.
We got time. Yeah, it's fine.
This guy. No, I don't want to save it.
It's already saved.
So this one is just Fedora 32. Same thing, not adjusting the network, but I am going to bump up the disk size a little bit. I almost did Control Shift again. Okay, so we'll let that import for a moment. So effectively what I'm going to do is, once this virtual machine starts up, I'm going to use Podman. So I'll do a DNF install Podman and then use Podman to start up just a very simple Apache web server on port 80 running on the virtual machine. And then we'll create a service that then exposes that particular web server. So again, we're using the pod network here. So remember that means it's only internally accessible. It's not externally accessible. And then we'll use a route pointing to that service to then expose it to the rest of the world. We should be able to do the same thing with SSH. We should be able to do the same thing with, if you want to install Cockpit or something like that, and have all of that running on the virtual machine. Alternatively, you can also do things like have a secondary interface, right? So one interface that's on the pod network, one interface that is on the a public network. So you could split your traffic that way. So my operating system administrator, maybe they're old school, they don't understand or don't want to understand all these routes and services and all this other stuff. They just want to SSH directly into the virtual machine. Well, great, all of that works. For my application team, I can expose my application across that pod network. Just add the route there for all of those networks. So expose it across that network, and then all of those application-centric things happen inside of the cluster across the SDN. Let's check our import here, which just finished. Man, that was good timing.
It's everything.
And we will start our virtual machine. I don't know if you can hear the server that all of this runs sits right over here. I don't know if you can hear the fan for it through my microphone.
No, is it firing up wildly or?
Yeah, I mean, it's always doing all of this stuff, right? It generates it's a Ryzen 5 with the stock cooler, because I keep meaning to get a new cooler, one that's quieter and more efficient. So it gets loud sometimes.
Nice. You should get one of those. You should just submerge it in that non-conductive liquid stuff.
Yeah. Have you ever seen that?
No, I haven't. No.
I was at where was it? I was at NetApp Insight in, I think, Berlin, and Cisco or somebody like that, Fujitsu, had like a blade chassis
Mhm.
that was submerged in whatever that non-conductive liquid is.
Some sort of oil.
Yeah, some kind of oil that's non-conductive. Yeah. But yeah, like, what was it? I was reading last week that Gartner pointed out that is going to be like a way to get more performance out of our CPUs to like keep up with Moore's law, is that like blade chassis encased in like cooling liquid, basically. It's like, well, okay, that's next level, but all right, let's add some liquid to the data center.
I worked at a place many years ago, and the way that they had done the power, space, and cooling was each rack was enclosed. So instead of being open racks with perforated tiles in front and air just trickles up,
yeah.
Rather, the racks were enclosed, and so they were able to have basically they required super high density. Like if you're not consuming like 40 kV or something like that per rack, don't even bother coming to us. So it was something like you had to have like high density blade chassis that were fully loaded to meet their requirements. Otherwise, it just wasn't worth their time, right? If you're only using a little bit of heat, a little bit of power to generate heat, it's costing them more than it was making.
Yeah, I worked for a company. We had it's basically like a tent or something around the data center aisles, right? Where it was the internal hot aisle was self-contained. And we had air coolers that pulled through the rack to cool that off that hot aisle area and keep air moving through it. And like it would get up to 100 something plus degrees in there very quickly, very easily in like a normal day. If it was like a summer day or something, it'd be like 150 degrees back there. You're trying to run cabling, you're sweating, it's crazy.
If you for anybody who's a NetApp customer, whenever the travel becomes a thing again, if you ever come to Raleigh, come to their RTP campus for an EBC or anything, ask for a tour of their data center. So they call them the GDL, Global Development Lab. So GDL1 was the first LEED certified like platinum data center, has a PUE of like 1.12 or something like that. And then GDL2, which was completed, I think 5 or 6 years ago, is even better than that. And they do something like 90% of the year is open air circulation, right? There's no active cooling. It's miserable to go to work in there because it's hot everywhere.
Yeah.
But they test, and they, their equipment is fully supported, like well beyond normal temperature ranges for many server vendors. All right. So enough rambling about.
Yeah. I could go on and on about heat and servers all day.
So I've got Podman installed here. The other thing that I want to do is check on SSH. So SSH is running. And I don't think the firewall gets installed with Fedora. I don't remember off the top of my head.
And not by default, no.
Yeah.
You did minimal too, so it's definitely not there. Yeah.
Yeah. So effectively at this point, we've got SSH, and I'm getting ready to start a Podman.
Container.
Yep, container for HTTPD. Thank you.
There we go. You're welcome. I like finishing your sentences. It shows how well we work together.
Again, remember the whole can't talk and type? Brain no worky.
I get it. Brain no worky when typey. I've got. Wow. Okay.
Now I'm going to struggle to remember what this is going to be.
What are you trying to do? Run just the web server?
Yep. I have a cheat sheet over here somewhere.
Is it an opensource.com cheat sheet? Can I get this cheat sheet, or is this your cheat sheet you made?
It's a so I have a markdown document that will turn into a log post that has all of this information in it.
Beautiful.
So
nice. I will be sure to share that blog post whenever it gets released.
So all I'm doing here, very, very simple. Podman run, demonize, call it HTTPD, map external port 8080 to internal port 80, and use the rel 8, the UBI HTTPD 2.4 or Apache 2.4 image.
Ta-da. T. Trapani says hi, by the way.
Oh, hello, Dustin.
And error.
Manifest. Why did...
Oh, you're not logged in.
I am logged in, but I think it's...
Oh, maybe you did type that. Sorry for the dog in the background.
I don't know why it didn't find... Oh, because this is Fedora, not RHEL. That's why.
Yeah, I was going to say on RHEL it's set up as a registry out of the box.
Yeah. So I had to specify the registry name, where as opposed to with RHEL, registry.redhat.io, I think is the first one in the search path.
Yes.
So we'll let that get fired up. And in the meantime, we will come over here to our networking tab, collapse that one for the moment, and create a service. So very, very super ridiculously simple. Although I think I do need to stop and restart my virtual machine based on my selector here. So we have our service that's been created. So we're using just a pod selector of app equals Fedora HTTP. So I'm going to cheat, and instead of restarting everything, I'm going to go over here to our virtual machine and edit the labels. Oh, app equals Fedora. I can just use that one. Ha. Every once in a while. What is that? A blind squirrel, even a blind squirrel finds a nut.
I like how even you questioned yourself on the blind squirrel gets a nut thing.
What am I looking for here? Services. App equals Fedora. All right. I think that'll work. Maybe. Possibly.
Maybe. We'll see. TBD.
Confusingly, I'm going to call both the route and the service the same thing.
Is that confusing, though? Or does that make things... Because they're labeled differently. Whatever.
The different resources, they just happen to have the same name.
Right.
Not available. Oh, no.
Did it not spin up?
It did. This is me probably not having the right label selector or something along those lines. So we'll cheat instead. We'll use vert control.
Okay.
So one of the things that is inside of here is an expose command.
Also, Andrew,
yes, sir.
Did you open it as a HTTP or HTTPS?
I did open it as HTTP.
Okay, I'm not sure whether it defaults. You know, just throw an S on the URL in your browser.
I could certainly try. It's the worst that happens.
Yeah.
It continues to fail.
No, it has a good cert or a bad cert.
No, it was the same.
Yeah. All right. So same thing as before: vert cuttle, vert control, vert CTL, expose. So the type that we have here, so VMIRS, VMI, and I'm trying to remember what those are at the moment. So we went cluster IP. So this is the name of our virtual machine, right? Rhys, I'm leaning on you to remind me how to do this.
Yeah, absolutely. So VMI is just the type. And so you leave VMI in there, and then you put the name of the VM.
Yep.
No, you had it right. Target is 8080, right?
Yes, that sounds right. All right, so we'll use vircontrol to cheat. And now if we look at our services, we see how we have our Fedora HTTP 2. You can see it did a much better job of filling in all of the different pod selectors. So one thing to note, and if you, one of the bugs that we found, and this was, I think it was both August on your team and Jafar on my team, you see it uses things like the flavor inside of here. So if you were to go in and change the flavor, it would cause the service to fail. So you can actually go in and you would want to edit the pod selector and remove some of these things just to prevent that from happening. I'm not going to do that here, but just be aware of that if you change some of these aspects that cause it to be relabeled, that can affect the selection. And then if we change our route here to -2, and this time it still doesn't work.
Did we get the ports right? No, see, target port there is 80 on.
Yeah, location.
But yeah, if you click on HTTP 2.
Let's restart then. So create route. Select a service, HTTP 2, target port is 80 to 8080. Oh, interesting. I'm not sure, unless our HTTP server isn't working, which is entirely possible.
Yeah, like, is it just off? Can you jump in and curl it? Make sure it's online or something?
Yeah, just look at curl localhost 8080.
Wow.
Yeah,
okay.
Connection refused. So,
well, you'd expect connection refused because you're on, because it is port 8080 that you need to get to, because it's only port 80 inside the container.
Right.
Yeah.
Right. So if.
But he's inside the container. Are you not?
Yeah, from there I am.
Oh,
yeah.
I didn't. Okay.
Yeah.
Yeah, if you can connection refused. So can you just go back to the VM and so you're in the pod there?
Do a PS.
I'm not in the HTTP pod. I'm on the VM.
Just on the VM.
Yeah.
So if you can't connect to localhost 8080, that means that it's not up. Because your container is listening on all interfaces on port 8080 and being pushed to port 80 inside of the container.
Mm-hmm.
I'm wondering if maybe that HTTP server doesn't have a default page.
That's entirely possible. But
connection refused.
Yeah, it
should that's true.
Something other than connection refused.
Just out of interest.
If it has nothing to serve,
does it have IP tables installed? I mean, but connection refuse, you wouldn't get
That could also be a
refuse.
firewall, yes. But
yeah, what's the IP? I haven't used IP tables
just
in
do
forever.
IP tables -L, capital L.
Yeah.
Yeah, that's empty.
Yeah.
And then firewall command's not there, right?
No, firewall command isn't there.
Okay, so
So
that's not it.
It's been a long time since I used IP tables directly and not through firewall command. So
Yeah. SC
all right,
Linux?
well, in theory, I just exposed SSH. So if we come back here to our services, so we have this SSH, which is going to port 22. So let's try it with that one. Create a new route. I think, do I use port 22 here? I don't remember.
No, you don't have to.
If I get the password right here, it could also not be enabled. Anyways, it's responding on
it's
SSH,
responding, yeah.
which is good. Now, why it isn't allowing Fedora to, it is the Fedora user, right? So it does work when you know what you're doing, sort of. When,
Right.
Why? Oh, I bet it's because it's probably key-based authentication only.
But I thought you built yours with the default user. Did you cloud-net this or not?
I did. So the problem is it's expecting a key. It only allows key-based authentication by default.
Got it.
And I didn't add a key. I just set a password.
Right.
So all I'm doing here is turning on password authentication. And then we should be able to come here and redo this guy. And
not get in.
Still not get in.
You changed the password of the Fedora user?
No, it's still Red Hat, all lowercase. Why are you not letting me in? Christian says I need to restart SSHD, which I did.
Set the password.
Interesting. Well, the good news is, even though I fail at both a web server administrator and a server administrator, it's at least responding, which means that our service and our routes worked for SSH. Why it's not working for HTTPD, I don't know.
Because the demo gods. That's who we're going to blame today for that. It's the demo gods.
I think it's namespace with the user, right?
Yeah, it is.
But the fact that you can't curl localhost 8080.
Yeah, that's weird.
Yeah, that's why it's not working.
Connection reset by peer. That's different.
Connection refused.
Connection refused. All right, that's weird. Connection reset would indicate that it's like not started. And then connection refused would indicate that it is started and is either A, doesn't have anything to serve, B, firewalled, or C, not actually started.
Oh, hang on a minute. What port does the RHEL 8 HTTPD server serve on? So go check the
80?
configuration file.
That would be inside the pod.
Are you saying
inside
the pod it might be a different config? Yeah, maybe.
Let me try and start this first. So let's do Okay, so this time, same thing, port 8080, just with a colon, not a semicolon. So I'm going to attach a volume of the current directory, which has that index.html, into var www html, and then our same Apache 2.4 container image.
Okay. Jesus. Yeah, I don't know, man. That's
You just
weird.
go into the container, podman exec.
Yeah. What?
What?
It's because you've volume mounted it.
No.
Yeah, you're right.
So this user doesn't have access to your home directory. But it's like /tmp or something. Or that.
One more time. Yeah, I know that doesn't exist.
Now it's probably SE Linux.
Yeah.
Not in the pod. Oh, you're not in the pod.
No, I'm not in the pod. Why did? Oh, because I'm not root.
Sudo.
Yeah.
I see the chat moving, but I'm not paying attention to it. Christian is going off.
He wants you to do set and force 9.
All right. Where did my exec command go? Still owned by root. Oh, you know what I didn't do? I did not change that. When I created the pod, I didn't change the volume mount.
No, you didn't. Christian asked, are you running the pod man command as a regular user?
Yes.
Yes. Isn't 80 a restricted port? Yes, 80 is a restricted port, but
8080 is not.
Yeah. So
Hey, there we go.
hey, that works.
Funny what happens when you do it correctly. All right. I don't.
But we also don't know which port it's running on and which
Yeah.
directory it's trying to
We
read files
need to
from.
look at the
Look at the
config.
configuration file.
Christian thinks it's under opt.
The quick way, just install HTTPD on as root. Skip the container thing. I know we're all meant to be container people here, but if it's just to prove that the root is working, then
Oh, Christian's gonna be so mad at you. His anger. raging Christian. Installed.
Now you're also going to have to edit the HTTPD configuration file to listen on port 8080 instead of 80 by default. You need to be root.
Still need to be root.
Yes. Yes, I do. All right.
Oh yeah. Also if you didn't notice, Christian, he turned off SC Linux.
Well, I set it to enforce the 0. What
Right.
am I looking for here?
Listen.
Thank you. I spaced out for a moment.
Yeah, listen on 80.
All right. There. All of that. Thanks.
Who needs
Thanks,
containers?
containers. Thanks, containers. All right. Let's come back to where did we leave all of this off at?
Yeah, where were we? Oh my gosh.
We still haven't proven that the root works yet.
One. Fedora HTTP. Let's clean up on some of these.
Yeah.
So service, create a service. Oops, not you. So we have 2 of these already. You, I want to go away. Yes. You, I want to go away. Yes. Now we'll go back to vert control. You get out of here. So target ports, blah, 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 blah. Okay. So vert control expose VMI Fedora. And then we want to expose port 80. So that's what it's going to listen on. And the target port is 8080. I think I need equals in these. Okay. So now if we come back here, we have it exposed on port 80. If we come to our route, let's delete our route and start over again. And now it fails. All right. Yeah, I'm not sure what's going on here. I've got something borked probably in that vert control expose, if I had to guess. The good news is 22 is working, so that's reassuring. Because
Yes.
we can SSH to it, even though I can't seem to administer SSHD.
But yeah,
I know my administrator card is being revoked as we speak.
Ouch. But this is like not simplistic or easy, right? Like what we're doing here. You're installing a VM on a container orchestration platform. and then trying to manage it, right? Like,
So yes, it should be. It shouldn't be as complicated as and this is simply Andrew doesn't often do this. So I haven't explored and found all of the rough edges yet, because most of the demos and interaction that I do are at the infrastructure layer. If Jafar is watching or listening, he's done this about a dozen times.
yeah.
And
if he were listening, he would have already chimed in. You know that.
Yeah, he's got a great demo. He has a great demo that shows Christian. Yeah, maybe it's my weird multi-tiered network. That's a good possibility too.
Oh, that's true. Yeah.
My wife keeps saying that if I get hit by a truck, she's just going to rip everything out and like pay Best Buy to come in and fix it. Anyways, so I know that this works. We've seen it with the Kodi demo. We've seen it with the demo that Bird did on stage at Red Hat Summit. We've seen it with a bunch of other things, including with Windows and .NET applications. I'm just not smart enough for it. It's beating me today. And what's funny is as soon as this ends, we can probably try it again. And it'll work 5 just minutes.
Fine. And if it makes you feel any better, today is my Monday, so it could be your Monday too, Andrew.
You know,
the route needs the port of the pod. Don't use port 80. I don't think you can do port translation, no problem. But try it. See what happens.
I'm also wondering if I screwed up the VMI.
Expose VM?
Yeah.
Oh. Wouldn't it have errored though?
I was just looking at our docs for the training, and we definitely do VMI. But CTL expose VMI, then the name of the service we want to give it, and then a port.
Yeah, this is.
Is this broken? Is this a weird network?
So the one thing we haven't done is actually proven that port 8080 is available outside of the root construct. So if you just go to any other pod and just try and curl the pod's IP on port 8080, do you still get that hello world? So go anywhere within the SDN.
Trying to think of what other pods we could use.
You can just do just use OC debug if you want, just a node.
Say that again.
So do OC debug node / then one of your machines, like a worker, because that should have access to the SDN. This is by far my most favorite way of getting to the hosts. Like anywhere that you have connectivity to the cluster with a kube config, get straight down to the host.
Do we want to use the service name or the pod?
I would just use the IP for now.
Yeah.
Just of the pod itself. So just the VM. Okay, so you know that it's definitely going to work from the outside. So it's just a problem somewhere with the way that you're exposing it.
Yeah, with the service.
Yeah.
So if we come to the service here. So it's funny. So from here, the service is responding just fine, right? That's the service IP that it's exposed on. So why isn't our route working?
That was on port 8080 you just did?
Port 80.
Oh, of course, because it's 80 on the outside. Of course.
So could this be...
now it's a route endpoint thing. does the target need to be 8080?
No,
That's an error page.
Yep. Application is not available.
Yeah.
So the service works, but my route doesn't work for whatever reason. So the good news is there is no good news. No.
Route doesn't go to service, it goes to the pod. Christian says, CS and temper. Check the YAML. Check the YAML. So target port 80.
don't you want target port 8080 as the target?
I don't know.
I don't think so, because the service is exposed.
We'll try it.
Yeah, we can try
Give it a whirl. There you go.
Of course. That was it.
That was it. Okay, cool. Thank you, everybody. Thank you. I need to figure out how to say these names.
So
Carlos
how did
Santana,
the
appreciate
target-
you. Thank you.
How did the target port go to 80 when we...
Yeah,
swear
I
we
thought
said
we
it.
switched it intentionally.
Well, that's so when we create the routes, that's the default that it's choosing for that service for whatever reason.
Huh. Okay. Interesting. So is this a bug? No.
We'll create another one
Yeah.
and see if that still goes to the target port of 80 when we want it to be a target port of 8080.
It's a feature. Carlos Santana says he can explain in chat. Well, this will be interesting. Carlos, read it in a way so that I can use a great impersonation voice. He doesn't want to type it all out, though. I can't blame him. Yeah, there it is.
That's even more strange. Because that's not using the default index in that case. So it's like it's listening on both.
Or, oh, no. Okay. Gears are turning. So if you go into the pod and do see what you can do. NetTools probably isn't installed, so you have to use SS, and I forget what the flags are to see which processes are opening which ports.
To netstat.
Yeah, the netstat-tu.
NPL.
Yeah, but I don't know if that's installed. I don't know if netstat would be installed on an 8 minimal.
The good news is that it's Fedora, and you can install whatever you like.
Yeah.
Not that you can't do that with RHEL, by the way. It's just...
Christian, I know the netstat command. I'm trying to remember the SS command. Yeah. I think it's like -L np or something like that.
Do it as the root user, and you get the process IDs if you want.
Mm-hmm. Yeah, so what's on 80? What's on 8080? Nothing's on 8080. There it is. Kubernetes NM. Huh. Weird.
Yeah, strange. And that's only on IPv6. So
Weird.
oh, yeah, that's an interesting one. I'm not sure. Let's come back to our console.
let's see. Okay, there's some explanation in the chat here. Okay. Carlos Santana says, service queue proxy is the one doing 80 to 8080. When another pod or microservice tries to hit service on port 80, then IP tables will do its work to route from port 80 to pod 8080. Nothing will be on port 80 in the pod. It will be on IP tables for service discovery using normal K8s Cube proxy. Cool. So IP tables -save would show you. Okay, try that. IP tables -save as one word. Or I can't tell if there's a space in there or not. Yeah, you got to do a sudo. There you go. Yeah, even better.
All right, so there's our 8080.
Yeah.
DNAT, yep, okay.
To destination 8080. Yeah, okay.
Huh, learned something new today.
Nice. Yeah, me too. Thank you, Carlos. Appreciate that.
So another thing I noticed, so this is inside of our virtual machine. It's only listening on IPv6 on port 8080. Not sure why that is.
No, they only use IPv6 inside the cluster. That's standard, right? I mean, IPv4 comes in when you give it an IP address. Everything else is v6 inside, right?
Try and force it there.
Ooh.
Failed to restart, which means I broke it again.
Oh, you didn't do it as root. Just because I'm reading everything Carlos Santana says today. By the way, this is something customers get confused a lot about when they go from ingress to using routes. They try to use the service port as target instead of pod port. Makes sense. Today I learned.
It's smarter than I am, apparently. So it being this thing has outsmarted me. So I'm going to continue to test and experiment with all of this. There's a blog post here that I'm going to publish in all of this of the correct way or the way that works and doesn't break while doing a live stream for Andrew around all of these things. Because I think it's something that there's a lot of questions out there about. I get asked them fairly frequently. So while it would have been nice to point those folks at the live stream to see a working example, I'll instead do that in a blog post instead of spending the next few minutes continuing to bang my head on the proverbial wall.
But your head's not flat yet. Anyways, so let's see. Eric says, I thought that the routes port was supposed to point to the services port. I think we kind of...
Yeah, so that's what we ended up doing that worked, right? So when we change this to the same as the service, this now works.
Right.
So my question is it a misconfiguration on my part, on the part of the service, on the part of the route that it's doing? See, target port 8080. I am inclined to think that it is a misconfiguration on the service, but at the same time, that would mean that the other services exposed using virtcuddle would exhibit the same symptoms or the same behavior, which we don't see with SSH, because again, even though I suck at administering Fedora, apparently, I can SSH to that particular host. Where is it? So SSH, and then if I specify my
You just did the
route here.
Yeah.
Yep. So we can see that that does work.
Yeah.
So yeah, I'm not sure what's going on here, and honestly, this is not an area that I have explored or experimented with enough to know off the top of my head what could be wrong. So thank you to those who are watching who have been helping with this. It has been incredibly helpful to me, and I've learned quite a bit in this process.
Andrew, I'm also wondering, that secure shell process you're just doing, change it to the core user and put your worker password in, your core password.
Oh, yeah.
If you know the password.
I don't know the password. So.
No, that didn't work because that should have been.
I was wondering whether it was going
key-based
to the host as opposed to the
route.
going through the. Yeah.
That was a good thought.
Yeah.
Well, at least let me SSH locally.
Privilege port.
The other one maybe to consider is no, so it doesn't work on port 443, but it should work on port 80. Right? No.
Wait, what were you trying to do?
I'm wondering if it's exposing it as a node port.
Oh, okay.
As opposed to a.
No, it's a cluster IP.
Yeah, see, the example here uses a node port. So, okay, I will take that as an action item.
Yeah,
and
that'll be fun to read.
Yeah, look into and explain how all of these ports are exposed and how a virtcuddle exposed differs from a service, differs from a route, and how all of those things hook together. So keep an eye on openshift.com/blog for that, and I'll start writing that this afternoon.
Sweet. Thank you. All right.
Well,
Anything else?
that's all I had to show. I think that was all I put in the synopsis.
Yeah, Rhys, you want anything else to say, share, do?
No, I don't think so.
Yeah,
Thank you
we've
for
I
letting
think
me be
we've
part
done
of
a
this.
thoroughly deep dive into this today. Yes. Wonderful.
Yeah. So if anybody has questions, concerns, problems, issues around disk images, right, creating images, importing images, etc., definitely feel free to reach out. You can also look at the so again in the GitHub repository for containerized data importer. So github.com/kubevert/containerized data importer. You'll find a ton of docs on how all of these things work inside of there. So it's a great resource. Just keep in mind that if you get an error, it is probably because of the API version, in that looking at upstream, the API version is going to be newer than the version that's in OpenShift Virtualization, at least for right now. So just keep that in mind. But otherwise, yeah, there's a ton of stuff that you can do inside of there. Definitely recommend checking it out. And then regarding the whole service and route thing, my apologies for that not working. I haven't paid my dues or to the demo gods or the stream gods or whatever it happens to be.
Yeah, maybe we paid the wrong gods. Who knows?
Yeah, we'll get that straightened out and turn it into a learning experience.
Awesome.
But otherwise, yeah, thank you, Chris. Thank you to everybody who's been watching.
Yeah, thank you, everyone. We really appreciate you tuning in. When in doubt, go to OpenShift.tv to learn the latest and greatest about what's going on. Tomorrow morning, first thing, 9 a.m. Eastern, not first thing for you, Rhys, 1300 UTC. We have the level up hour. We're talking about helper scripts in containers. So this is how to take those things that you would normally have running around on your file systems, scripts and everything, and actually containerize them and run them as containers. So it's going to be interesting with Langdon White, my teammate, our teammate Andrew, at 9 a.m. Eastern, and then at noon Eastern, OpenShift Commons. We'll be talking about GPUs on OpenShift. So that'll answer some of our GPU questions from earlier. So that'll be fun.
So, yeah. I didn't say thank you to Rhys. I know it's later in the day for you, Rhys. So do appreciate you.
Yeah, no kidding.
Helping and participating.
Worries.
Yeah, really appreciate you, Rhys. Thank you. Without further ado, everyone stay safe out there, and thank you for watching.